In this video, we're going to focus on adding vectors analytically. So a vector is a quantity that has magnitude and direction. So let's say if we have a force vector that's 100 newtons directed towards the east. The magnitude is the size of the force, it's 100 newtons, and the direction is east. And let's say if we want to add it to another force that's directed east as well, and let's say it's 50 newtons. So the resultant sum of these two forces is going to give us a net force of 150. Whenever you have two vectors that are parallel to each other, you can simply add the numbers to get the resultant sum. Now let's say if we have a 200 Newton vector directed east and a 120 Newton vector directed west. What is the resultant vector, and also specify the direction? So this is positive 200 because it's directed towards the right. This is negative 120 because it's directed towards the left. If you add these two, you should get a net force of positive 80. Now it's going to be smaller than the original one, but it's still directed east because this vector is greater than this one. Now as another example, let's say if we have a force vector that's 60 newtons directed east and another one that's 90 newtons directed west. What is the resultant force vector, and what's the direction? So this is positive 60, that's negative 90. So we're going to have a net force of negative 30 newtons. Or you could just say 30 newtons directed west. Now, what if we have a force that's 80 newtons directed north and another one that's 120 directed south? So 120 minus 80 is 40. So the net force is going to be 40 directed south. And if you recall, this is north, south, east, west. Now sometimes you may need to add two vectors that are not parallel or anti-parallel to each other. So let's say if we have a 30 Newton force vector directed east and a 40 Newton force vector directed north. What is the resultant force vector? If you have two vectors that are perpendicular to each other, you could find the resultant force vector by finding the length of the hypotenuse of the right triangle that is formed. So therefore, the resultant force vector is going to be the square root of F1 squared plus F2 squared. Let's call this F1 and this force F2. So it's going to be the square root of 30 squared plus 40 squared. If you're familiar with the 3, 4, 5 triangle, then this is going to be the 30, 40, 50 triangle. So the resultant force is going to be 50 newtons. Now sometimes, in addition to finding the magnitude of the resultant force vector, which is 50, you may need to find the direction as well. So you got to find the angle theta. To find it, you can use this formula. It's the inverse tangent of the y component divided by the x component. So the force in the y direction is 40 and the x direction is 30. So to find the angle, it's going to be arctangent the opposite side, which is the y value of 40, over the adjacent side, which is the x value of 30. Hopefully you're familiar with SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite relative to theta over the adjacent side. The arctangent of 40 over 30 is 53.1 degrees. So we could say that the resultant force vector has a magnitude of 50 newtons and a direction of 53.1 degrees relative to the x-axis. Let's try another example. So let's say if we have a force vector that's 50 newtons directed west and another one that's 120 newtons directed south. Calculate the magnitude of the resultant force vector and find the direction. So let's draw a triangle. So this side is 50, and this side is going to be 120. So the resultant force vector is the hypotenuse of this triangle. So notice that it's in quadrant 3. Now, if you're familiar with the 5, 12, 13 triangle, then the hypotenuse has to be 130. So the resultant force vector is going to be the square root of 50 squared plus 120 squared, and that's going to turn out to be 130 newtons. So that's the magnitude of the resultant force vector. Now all we need to do is find the angle. So first, let's find a reference angle. To find a reference angle, use the arctangent formula. Take the force in the y direction, divided by that in the x direction, but make it positive initially. This will give you an acute angle between 0 and 90, and then you could adjust it later. So arctan 120 over 50 will give you a reference angle of 67.4. So here's the reference angle. It's inside the triangle. Now what we need is the angle relative to the positive x-axis. So if this is 180, then the resultant vector is 180 plus 67.4 relative to the x-axis. So it's at an angle of 247.4. So therefore, this is the resultant force vector, which has a magnitude of 130, but an angle of 247.4 degrees. So that's the answer. Now let's say if we have a force vector of 45 newtons directed east, and we wish to add it to a force vector of 60 newtons directed south. Find the magnitude of the resultant force vector and also the angle. So let's draw a triangle. So this is 45 and this is 60. So let's find the magnitude of the resultant force vector. So it's going to be the square root of 45 squared plus 60 squared. Which is 75 newtons. So that's the magnitude. Now we got to find the angle. But let's find a reference angle first. So it's going to be arctangent, the force in the y direction, divided by the force in the x direction. So that's 60 over 45. Which is 53.1. Now that's the reference angle. The first force vector is positive. It's directed east. The second one is directed south. So therefore, the resultant force vector is in quadrant 4. Now, if this angle is 53.1, to find the angle relative to the positive x-axis, it's going to be 360 minus 53.1. Keep in mind, a full circle is 360, but you need to go back 53.1 degrees. So 360 minus 53.1 will give us an angle of 306.9. So the resultant force vector has a magnitude of 75 newtons, and it's directed at an angle of 306.9 degrees relative to the positive x-axis. So this is the answer. So if you know the resultant force vector is going to be in quadrant 1, then the angle is going to be the same as the reference angle. And keep in mind, the reference angle can be calculated by taking the inverse tangent of the force in the y direction divided by the force in the x direction. And if you always make these positive, you're always going to get an acute angle between 0 and 90, which is the reference angle. Now, if you know the resultant force vector is in quadrant 2, then to find that angle, it's going to be 180 minus the reference angle. If it's in quadrant 3, we covered this one already, it's 180 plus the reference angle. And if you get an answer that's in quadrant 4, it's going to be 360 minus the reference angle, which was the case in the last example. So it's helpful to know these things, or you could just see what to do visually once you graph everything. Now sometimes you may need to add vectors that are not parallel or perpendicular to each other. So let's say if we want to add this vector, which is 100 newtons directed east, plus another vector, let's say it has a magnitude of 150, but it's directed at 30 degrees above the x-axis. How can we find the resultant vector? First, let's relist what we have. The first vector has a force of 100 newtons, and its angle, it's east, so it's on the x-axis, so it has an angle of 0 degrees. The second force vector has a magnitude of 150 newtons, and it has an angle of 30 degrees relative to the x-axis. Now, what you want to do is you want to add these vectors using the component method. So you want to break these forces into their components, add their respective x and y components, and then you could find the resultant force vector. So let's say if this is a force vector, this is the x component, and this is the y component. And here is the angle. F of x is equal to f cosine theta, and f of y is f sine theta. F, you can find it by using Pythagorean theorem. It's f of x squared plus f of y squared. And the angle theta is the arctangent of f of y divided by f of x. So those are some formulas that you're going to find useful in this portion of the video. So what we need to do is find f1x and f1y. So f1x is going to be 100 cosine of 0. Cosine of 0 is 1, so 100 times 1 is simply 100. f1y is going to be 100 sine of 0. Sine of 0 is 0. 100 times 0 is going to be 0. Now, let's do the same for f2x and f2y. f2x is 150 times cosine of 30 degrees. Now, if you type that in your calculator, make sure it's in degree mode. So this will give you, as a decimal, 129.9 newtons. f2y, that's going to be 150 times sine 30, which is just 75. Now what we need to do is add up the x components. So if we add those two values, the sum of the forces in the x direction is going to be 100 plus 129.9. So that's going to be 229.9. And then we need to find the sum of the forces in the y direction, which is just 0 plus 75, so that's simply 75. So f of x is 229.9 newtons, and f of y is simply 75 newtons. Now let's go ahead and draw these values on an xy plane. So f of x is 229, and f of y is 75. The resultant force vector is the hypotenuse. And to find it, it's going to be the square root of f of x squared plus f of y squared. So you should get 241.8. So that's the resultant force vector. That's the magnitude of it. Now that we have the magnitude, we need to find the angle. So it's going to be arctangent f of y, which is 75, divided by f of x, which is 229.9. So the angle, which is already in quadrant 1, is 18.1 degrees. So now we have the magnitude and the direction of the resultant force vector. Let's try another example. So let's say that F1 has a magnitude of 150 newtons and it's directed 60 degrees from the x-axis. And F2, let's say it has a magnitude of 200 newtons and it's 30 degrees below. Actually, let's say it's 40 degrees below the x-axis. So using this information, go ahead and find the magnitude and the direction of the resultant force vector. So first, it's good to write it out. F1 is 150 newtons directed 60 degrees from the positive x-axis. F2 is 200 newtons and it was 40 degrees below the x-axis, so that's in quadrant 4, so you need to use 360 minus 40, which is 320. So it's at an angle of 320 degrees, which is the same as negative 40. Now, let's find F1x and F2x. I'm going to line up the x components on the left side. On the right side, I'm going to put the y components, F1y and F2y. So F1x, that's going to be 150 times cosine of 60, which is 75 newtons. F2x is 200 times cosine 320, and that's going to be 153.2. F1y is 150 sine 60, which is 129.9. F2y is 200 sine 320, and that's negative 128.6. The reason why it's negative is because this angle is in quadrant 4, and the y component is negative in quadrant 4. So now, let's add up the values. So the sum of the forces in the x direction is going to be 75 plus 153.2, which is about 228.2 newtons. The sum of the forces in the y direction is 129.9 plus negative 128.6, which is positive 1.3. So therefore, because x and y are both positive, the resultant force vector is going to be in quadrant 1, between 0 and 90. Now let's find the magnitude of the resultant force vector. It's going to be the square root of f of x squared plus f of y squared. Now because f of y is so small, the resultant force vector should be approximately the same as the x component. And it really doesn't change much. It's like 228.203, which is still about the same. Now let's find the angle. So it's arctangent y divided by x, 1.3 divided by 228.2. So the angle is about 0.33 degrees. So let's draw this. So the x component was about 228.2. The y component was very small, maybe like 1.2 or 1.3. And as you can see, the resultant force vector is basically almost parallel to the x-axis. And so this angle is about 0.3 degrees if you want to draw everything. Now let's try one more example. This time, we're going to find the resultant force vector given three vectors. So let's say the first force is at 300 newtons directed west. The second one is at, let's say, 400 newtons directed south. And the third one is 500 newtons at an angle of 50 degrees. So we're going to say F1 is 300 newtons at an angle of west is at 180 degrees. And F2 is 400 newtons directed south, which represents an angle of 270. And F3 we said is 500 at an angle of 50. So let's find F1x, F2x, and F3x. And then we'll find the sum. And let's find F1y, F2y, and F3y. Let's start with F1x. That's 300 times cosine 180. Cosine 180 is -1. So this is going to be negative 300 newtons. Now F2x, that's 400 cosine 270. Cosine 270 is 0, so the whole thing is 0. F3x, that's going to be 500 times cosine of 50. And I got 321.39, which I'm going to say 0.4. Now F1y, that's 300 sine of 180, which is 0. F2y, that's 400 sine of 270, which is negative 400. And F3y is 500 sine 50, which is positive 383, and that's it. So now let's add the x and the y components. So the sum of all forces in the x direction is going to be negative 300 plus 321.4, which is simply 21.4 newtons. And the sum of all forces in the y direction is negative 400 plus 383, which is negative 17 newtons. So now that we have f of x and f of y, let's find the magnitude of the resultant force vector. So it's going to be the square root of 21.4 squared plus negative 17 squared. So I got a magnitude of 27.3 newtons. Now let's find the angle. So this is going to be arctangent. Now make everything positive, y and x. So f of y, 17 over f of x, which is 21.4. When you make it positive, this will give you the acute angle, the reference angle between 0 and 90. So arctan 17 divided by 21.4, that's 38.5 degrees. Now let's draw a picture. So f of x is positive, f of y is negative. So the resultant force vector is going to be in quadrant 4. So this is 21.4, and this is negative 17, and hypotenuse is 27.3. Now the reference angle is 38.5. If you recall, if you want to find the angle in quadrant 4, it's 360 minus the reference angle. So in this case, it's going to be 360 minus 38.5, and that's going to be 321.5 degrees. So this is the magnitude of the resultant force vector, and this is the angle relative to the positive x-axis. So just to review what we've learned, whenever you have two vectors that are parallel, you could simply add them. if you have two vectors that are anti-parallel or opposite to each other, you can subtract them. So this will be 50 minus 20, which is 30. Now, if you have two vectors that are perpendicular to each other, you can use the Pythagorean theorem to find the resultant vector. So it's going to be the square root of 30 squared plus 40 squared, which ends up being 50. And you know how to find the angle at this point. Now, whenever you're adding two vectors that are not parallel or perpendicular, then you need to resolve it into components. You need to find all of the x components, as we've dealt before, and all of the y components. And then find the sum. You want to find the sum of all the x components and the sum of all the y components. Once you have that, then you can find the magnitude of the resultant force vector, and then you could find the reference angle using this equation. And remember, to find the components, you can use this. F of x is f cosine theta, and f of y is f sine theta. Now, if f of x and f of y are both positive, it's located in quadrant 1. If f of x is positive, but if f of y is negative, then the answer is in quadrant 4. If f of x is negative and f of y is positive, then the angle is in quadrant 2. And if they're both negative, it's in quadrant 3. And remember, if you have an angle, if the resultant force vector is in quadrant 1, where f of x and f of y are positive, the angle is simply the same as the reference angle, which is arctan f of y over f of x, and make these two positive. If it's in quadrant 2, then it's 180 minus the reference angle. If it's in quadrant 3, the angle that you want relative to the positive x-axis is 180 plus the reference angle. And in quadrant 4, it's going to be 360 minus the reference angle. So now you know how to add vectors using the component method. So that's it for this video. Thanks for watching, and have a good day.